Today on Capechi's Corner, we're going to look at proofs involving special parallelograms. In our first proof, we know we're trying to prove that ABZY is a rhombus, but my given information, I know that ABZY is a parallelogram. I also know that ZY is congruent to BX, because that's given, and I know that angle 1 is congruent to angle 2. So all of these three things are given. So in trying to get to a rhombus, I can either say that all four sides are congruent, and that would be the reason it's a rhombus is because of the definition of a rhombus, or we have the theorem stating that if I can find two consecutive sides of a parallelogram that are congruent, then I can state that that parallelogram is a rhombus. So let's see what our given information we can get out of that and where our proof will go. So I know that angle 1 is congruent to angle 2. So because of that, I can say that segment BX is congruent to segment BZ. And I'm going to mark that. And the reason I can say that is because that's the converse of the Isosceles Triangle theorem. So converse of Isosceles Triangle theorem, and that states if I have two angles that are congruent, the sides opposite those angles are also congruent. Now, because of that, I notice now that I have BZ is now congruent to ZY, and that is because of, it looks like I have to decide whether I have transitive or whether I have substitution. In this case, it looks like I have transitive. Maybe the way you wrote it would be a different pattern would be a substitution, but I have transitive. Now at this point, I do notice that I have two consecutive sides of that parallelogram are congruent, which makes that a rhombus. So I can actually go right to my last statement, and I can say ABZY is a rhombus. And the reason is if two consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So I'm all set. Now, if I wanted to go and try to prove that all four sides were congruent, if I want to do it a different way, I could say that BZ and AY are congruent, and I could also say that AB and ZY are congruent because of opposite sides of a parallelogram are congruent. Therefore, with some substitution, I could say that all four are congruent. Therefore, it's a rhombus by definition of a rhombus. But again, the reason we can go a little quicker is because I realize that I have two consecutive sides of that parallelogram are congruent. In our next proof, we're given information that I have a rectangle QRST. So QRST, I'm going to mark it. We have a lot of stuff going on right here. So QRST, that's my rectangle. You have that little yellow highlighter. I also know that I have a parallelogram, RKST. So RKST, this piece right there is a parallelogram. And I'm trying to prove that I have isosceles triangle. So again, I have a lot going on. So this QSK is isosceles. So that's what I'm trying to prove. Now that's a lot. I need to figure out, I need to pay attention to the properties of a rectangle, the properties of a parallelogram. I know that with an isosceles triangle, if I can prove that two of those three sides are congruent, then it's isosceles. So that actually becomes my goal. Okay, so at this point, we're just going to start somewhere. If we realize that a property that I'm using we don't need, we can always go back and erase it. But I do notice with a rectangle that I know that my diagonals are congruent. So that rectangle, I have QS is congruent to TR, and that is because the diagonals of a rectangle are congruent. Okay, so I'm going to mark that. So I have QS, so this piece right here is going to be congruent to TR right there because of the fact that they're diagonals of a rectangle. I also know, and again, trying to focus on that triangle, I also know that TR is congruent to SK because I can get that from my parallelogram, and that is because opposite sides of a parallelogram are congruent, so I'm going to mark that as well. Now, once I do that, I do realize on that triangle I have two of the three sides that are congruent, so I just need to state that now. I need a little bit of a substitution. So I can say that QS is congruent to SK. And similar to my last proof, I need to figure out if did I use transitive or did I use substitution. It looks like I happen to use transitive again, so it really depends on how you write it. Now from there, once I have stated that those sides are congruent, I know that I have isosceles triangle. So I have triangle QSK is isosceles, and that is because of a definition of isosceles triangle, because isosceles triangle, the definition states that if two of the sides are congruent, then the triangle is isosceles.